This planet is as light as a piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years away from us, so we'll never see it with our own eyes. It has an extremely low density, which combines with other features, like its high temperature and the infrared brightness of its host star. And all this makes it really special. Interestingly, the planet's radius is 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their parent stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered. The thing is, if you're that close to your star, and mostly made of a hydrogen-helium cocktail, you're not going to keep your puffiness for long. It's like trying to hold onto a balloon during a hurricane. A world similar to this would look puffy for a few tens of millions of years, not more, while the star is very young and hot. But here's a problem. The star our cotton candy planet orbits is estimated to be around 6 billion years old. By no means is it young. Potentially, there could be some mechanism for internal heat puffing up the atmosphere of the planet. But the properties astronomers have observed can't be recreated even with the help of complex planetary evolution models, even under the unrealistic assumption of a coreless structure. It makes WASP 193b a true cosmic mystery, and solving it will require more theoretical and observational work. Gas giants which are close to their host stars are great for observation. According to our understanding of planetary formation, even though they had to have formed within their home star system, it still happened further away from the star. And then they migrated inward, closer to the star. Our cotton candy planet orbits a sun-like star named WASP 193. This star is about 1.1 times the mass and 1.2 times the radius of our sun. Plus, it's very close to the sun in age and temperature. But the cotton candy planet travels much, much closer to its star than any of the planets of the solar system. It zooms around it every 6.25 days. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 107b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet has something in common with our Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure. But WASP 107b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or, as you might know it, sand. Imagine sand castles in the sky.
August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now, picture this. future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They've become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis 2 is set to carry astronauts to lunar orbit in 2024, and during Artemis 3, which should take place in the mid-2020s, 2 astronauts will touch down near the moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and 2 planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its 2 giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claim to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
And will start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios, more of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests, they can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora. We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, Are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES-2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES-2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES-2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES-2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just one day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Perhaps one of the most perplexing aspects of our solar system is the fact that not every planet is a lovely solid sphere like our Earth. Some are almost entirely made of gas. If you visited Jupiter, you wouldn't be able to stand on its surface. You'd likely fall through its gaseous layers, all the way down to the planet's core. You'd have to survive an incredible amount of pressure before hitting its potentially rocky core. Whatever the case, mysterious gas orbs have always intrigued scientists. Luckily, now they have the James Webb Space Telescope to satisfy their curiosity. The incredibly powerful infrared eyes of this instrument see much more than what the telescopes of the past could spot. And recently, a team of researchers announced they may have noticed something interesting about the dynamics of gas giant formation. All thanks to James Webb. Soon, we might be able to answer how long gas giants have to form around their parent stars before all the gas around those stars fades away. At the moment, it seems like this period of time isn't too long, but there are some nuances. The team used the Webb telescope to probe the disk wind. This name doesn't really refer to any kind of wind. Instead, it refers to the process of gas leaving a disk around a star. The so-called disk, also known as a protoplanetary disk, is filled with various stuff and has the potential to give birth to planets. Astronomers knew such disks existed and could play an important role in disk evolution, but they couldn't figure out the underlying physics or estimate how much mass was lost in the process. Now, they might be able to do so. The wind disk studied by the team seems to move at a rate of 6 to 9 miles per second, which is quite slow for something moving in the vastness of space. Fast-moving gas patterns, known as jets, can boast speeds of more than 62 miles per second. The researchers haven't come to any specific conclusion about how long gas planets have to form before depleting protoplanetary disk gas completely. But based on their preliminary calculations, it might take about 1,100 years. Even though it sounds like a really long time for us Earthlings, in astronomical terms, it's an incredibly short timescale. For comparison, a protoplanetary disk can live for 5 to 10 million years. One of the main difficulties in examining disk-wind movements is finding a protoplanetary disk. But our solar system doesn't have any. All our planets are formed and complete, including gassy ones. That's why the team found another target, a disk around a young, low-mass star called T-Chi. This star, lying 350 light-years away from Earth, is quite interesting in its own right. It has a large dust gap in its disk. It's thought to be created by a planet or planets, consuming all the material on its way around the star. Such a gap may suggest that the star has budding planets orbiting it. It's also old enough for those nascent worlds to munch on parts of the disk itself. It might be what we know as the transition stage, moving from a protoplanetary disk to a solar system-like structure. So, the perfect disk subject was found. It was time to track some neon, a peculiar gas great for disk exploring. It's one of the gases that are more likely to exist in protoplanetary disks. Plus, neon spits out electrons at pretty modest temperatures, which makes it easier to spot. After examining the region with the help of the JWST, scientists concluded that neon was indeed coming from further away from the star. But that was not all. Along with neon, the team found argon. It has been seen in several protoplanetary disks before, but its traces have never been this strong. Some senior researchers thought it wouldn't be possible to see them so clearly, but thanks to James Webb, and after vigorous tests, the results were confirmed. These results are a small but crucial step in understanding more about the mind-boggling nature of gas planets.
There are 8 planets in our solar system, and they're all very different from one another. That's why, if one day they unexpectedly and inexplicably turned into humans, these people wouldn't look alike, and their characters would differ dramatically. Let's try to imagine what humans the planets of the solar system would make. Do you like our videos? Write about it in the comments, and please subscribe to our channel. Let me introduce Mercury. It's a curious and swift teenager around 13. 15 years old. He's always on the move and is a bit hard to pin down. He's into sports and tends not to walk but dash around. That's one of the reasons his knees and elbows are always scratched. He's just like the planet Mercury with all its countless craters. Now, meet Venus. It's a beautiful young lady in her mid-20s. She likes to keep her secrets, and her alluring beauty comes with a temperamental side. At parties, she easily attracts attention because of the mystery surrounding her. But those who dare strike up a conversation with this beauty soon realize that she's scorchingly direct and doesn't tolerate nonsense. Earth is in her late 20s. She is very pretty and extroverted, and has a nurturing, balanced personality, forever the peacemaker, trying to maintain harmony. Earth is the one everyone turns to for advice and comfort. She has a pretty unusual hobby, collecting different life forms like someone who always brings home stray animals. And if she feels that something or someone is a threat to her beloved pets, she can get furious. Mars is a cool guy in his early 20s. He's ginger and sturdy. He's that ambitious and a bit annoying younger brother, living in Earth's shadow. But he doesn't give up and is determined to make a name for himself. He's a great fan of adventure and exploration, that very type who enjoys camping, wilderness, and slightly dangerous activities. His guilty pleasure is Googling stories about ancient warriors. Jupiter is in his early 50s. He is that protective elder with a bigger-than-life personality. He is a respected head of a large family, known for his wisdom and jovial nature. He also loves to throw big parties that sometimes get out of hand. Saturn, an elegant lady in her late 40s, is stylish and timeless. She is always the best-dressed person at any gathering. She's known for her beauty and has a calm, sophisticated demeanor. She loves accessories, especially elaborate rings. She's got quite a collection. Uranus is in his late 30s, and he has an unconventional, quirky personality. If you have a problem and need a different perspective on something, he's the one to go to. No wonder his planet counterpart has a unique axial tilt. Uranus isn't afraid to be different. He enjoys innovative and boundaries-pushing art, and some suspect he might be a hacker. Neptune is a thoughtful man in his early 40s. He's kind of a dreamer and probably the most creative one in the group. You can often find him lost in thought or swept away by music. He's almost always wearing his large blue headphones. He's very sensitive and has a high emotional intelligence. This quality draws others in. That's not all. Let's look at a space body that used to be a planet, Pluto. It's a very young teenager, quiet and often overlooked. But he has a surprising amount of depth. Despite his introverted nature, he has a group of close-knit friends. It might take time to get to know him, but those who gain his trust discover his different side, endearing and witty. The son is a big boss. No one knows how old he is because he looks ageless. Rumor has it he frequents beauty clinics, but shh! The son knows his worth and uniqueness. He's quite caring and nice to his subordinates, but he's also rather hot-tempered, and when he gets angry, he expresses his displeasure openly, often by throwing stuff. The moon is a shy 18-year-old girl. It's hard for her to make new friends. She prefers to keep close to the only friend she has, which is Earth. To her, Earth is a motherly figure who can protect and give valuable advice. The moon has some skin problems, which also makes her feel rather insecure. But don't worry, Earth is working on her confidence. How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaetons was a good story, it's not popular anymore. As we venture deeper into cosmic exploration, we encounter a plethora of exoplanets that defy our Earth-centric notions of what a planet should be like. From pitch-black gas giants to planets being torn apart by their own stars, these strange worlds offer a sobering glimpse into the extreme and varied conditions the universe harbors. In this overview, we delve into some of the most peculiar, hostile, and enigmatic planets known to humanity. Tres 2b. Located in a remote corner of the universe, Tres 2b is a world where darkness reigns supreme. Forget a sky filled with twinkling stars or even the barest sliver of a moon. Here, it's an abyss of darkness. This gas behemoth is 1.5 times more voluminous than Jupiter and possesses an uncanny ability to absorb light even more efficiently than charcoal. It's a place where photons go to die. Its atmosphere, torrid and choking, may occasionally display a dark ruby-red hue caused by air heated to temperatures similar to molten lava. It's a world that flips our understanding of night sky on its head. 55 Cancri E. Within the 55 Cancri system, a peculiar hellish world orbits its star in an uncomfortably tight dance. 55 Cancri E is subjected to such intense heat that half of its planetary face has become a seething ocean of molten lava. Picture an entire hemisphere ablaze, a burning sea without end. The other half is a perpetual desert of darkness, never touched by the light of its nearby sun. And between these two extremes lies a narrow band of perpetual dusk, where twilight lasts forever. The stark contrast between the burning and the desolate creates an eerie landscape of hopelessness. HD 189733b. At first glance, you'd think HD 189733b is an artist's impression of an alien ocean world. Its surface appears to be beautifully patterned with swirls of blue and white, but this beauty is deceiving. Those captivating patterns are the result of silicate particles in the planet's turbulent atmosphere, which conspire to create a storm of glass rain. That's right, glass shards falling from the sky, propelled by winds reaching speeds of 5,400 miles per hour. Anything and everything in its path would be ripped to shreds in moments. PSRB 1257 plus 12. Imagine a place where your very atoms are torn apart. That's what is happening to the planets in this system, thanks to their parent star, a pulsar. Pulsars are the remnants of exploded stars, and they release potent electromagnetic pulses. These energy bursts are gradually erasing the existence of the exoplanets in this doomed system, breaking them down at an atomic level. Their fate is to slowly dissipate into the cold void of space. Kepler 70b. Once upon a time, Kepler 70b might have resembled Jupiter, a gas giant enveloped in a thick atmosphere. But its parent star went through an explosive midlife crisis, expanding into a red giant and gobbling up Kepler 70b in the process. Now, this planet is a fiery rock with temperatures that exceed those on the surface of the sun. The extreme heat is causing the planet to evaporate. Its days are numbered. WASP 12b. Tragic might be the most fitting word for WASP 12b. Its massive parent star is pulling it into an oblong shape, reminiscent of an egg. As it spirals closer, the gravitational pull becomes even stronger, signaling an inevitable fatal attraction. In a cosmic time frame, WASP 12b is already on its deathbed. Gliese 436b. Imagine a world so contradictory that it boggles the mind. Gliese 436b is both scorching hot and eternally icy at the same time. Despite being hotter than an oven, its surface ice doesn't melt away. Instead, it burns continuously due to the planet's intense gravity, which keeps it solid. Venus, our neighboring planet, is another nightmarish world. With a hellish atmosphere, corrosive sulfuric acid rains, and surface temperatures that even outstrip those of Mercury, it is truly Earth's evil twin. Dimidium is another inhospitable planet, tidally locked to its star. One side is scorched to temperatures exceeding 1,800 degrees Fahrenheit, while ferocious winds of 600 miles per hour sweep the surface. This gas giant even experiences molten iron rain.
For a few decades, scientists have been debating whether there's a mass gap between the heaviest neutron stars and the lightest black holes. And finally, for the first time ever, researchers have discovered an object with a mass falling right into this gap. It started on the 29th of May, 2023. The LIGO Livingston detector in Louisiana recorded a mysterious signal. It was produced in the process of a merger of a neutron star with an unknown compact object. It was most likely an unexpectedly lightweight black hole. Its mass could be just a few times that of our Sun. That's why this object falls into the lower mass gap between the lightest black holes and the most massive neutron stars. According to Einstein's theory of general relativity, neutron stars are likely to be lighter than 3 times the mass of our Sun. But the exact mass after which a neutron star will collapse into a black hole is still unknown. And considering our previous electromagnetic observations, we can expect to find very few black holes or neutron stars within the range of 3 to 5 solar masses. And still, the mass of one of the newly discovered objects perfectly aligns with this range. But let's have a better look at how the situation with the LIGO detector unfolded. Just 5 days after the launch of the 4th observing run, things became really exciting as the detector recorded a gravitational wave that was classified as signal candidate S23059A. The online analysis was performed almost in real time as the signal arrived, and the conclusion was astounding. A neutron star and a black hole most likely merged around 650 million light-years away from our planet. Unfortunately, it's impossible to say exactly where the merger had occurred since only one gravitational wave detector was recording scientific data when the signal arrived. That's why the direction from which the gravitational waves came wasn't determined. And still, the researchers were sure that the signal wasn't some local disturbance in the LIGO Livingston detector. It actually came from deep space. To figure out the properties of the space bodies that orbited each other before merging and producing the gravitational wave signal, astronomers compared data from the LIGO Livingston detector with 2 waveform models. The detected signal appeared as a result of the merger of a compact object with 1.3 to 2.1 times the mass of the Sun, and another compact object with 2.6 to 4.7 times the Sun's mass. Were these compact objects a neutron star and a black hole? We can't tell for sure using gravitational wave analysis alone. But based on everything we've learned about the properties of this binary, astronomers think that the lighter object is a neutron star and the heavier is a black hole. Of all the neutron star-black hole mergers we've detected so far, the most recent one is also the one in which the masses of the 2 participating objects are the least different. Experts explain that if a black hole is way heavier than a neutron star, no matter will be left outside the black hole after the merger. No electromagnetic radiation will be emitted either. As for lighter black holes, they can rip neutron stars apart with their strong tidal forces. In the process, they eject matter that might glow as a kilonova or a gamma-ray burst. The detection of this interesting phenomenon became possible due to several improvements made to the detectors, which increased the sensitivity of the equipment. The highly successful 3rd observing round finished in spring 2020 and brought the number of known gravitational wave events to 90. The 4th observing round started in May 2023. Researchers at an institute in Hanover, together with their LIGO colleagues, have improved the laser sources of the LIGO detectors located at the heart of the instruments. Along with hardware, experts have also worked on other features of the detector. And now, these space exploration tools can figure out the properties of black holes within mere days.
A super-Earth, ready to be explored, is floating in space relatively close to us, a mere 337 light-years away from our planet. The term super-Earth is used to describe a planet beyond the solar system, with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. Their masses are 14.5 and 17 times that of our planet, respectively. The term also refers only to the mass of the planet, not its habitability or surface conditions. But the coolest thing about this newly discovered super-Earth is that it might harbor a second, Earth-sized planet. The bigger planet is dubbed TOI 715b. It orbits within the conservative habitable zone of its parent star. Moving within this region means there might be liquid water on the planet's surface. Of course, several other factors need to line up for the surface water to appear. But the conservative habitable zone, unlike the optimistic habitable zone, makes the planet a great candidate for harboring water. As for the smaller planet, it's likely to be just a bit larger than Earth, and it might also dwell inside the conservative habitable zone. NASA's James Webb Space Telescope, as well as other new spaceborne instruments, are designed not only to detect distant worlds, but also to reveal some of their main features, including the composition of their atmospheres. And based on this knowledge, we can get clues to the possible presence of life there. The newly discovered super-Earth, TOI 715, orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within the star's habitable zone. Tighter orbits also mean that planets cross the faces of their stars more often. In the case of TOI 715b, it's once every 19 days. That's how long a year in this mysterious distant world lasts. Star-crossing, or transiting, planets can be detected more easily and observed more frequently. And it's great for TESS, the Transiting Exoplanet Survey satellite, which found the new planet. This satellite has been adding to a long list of habitable zone exoplanets since its launch in 2018. Unfortunately, observing such transits for Earth-sized planets moving around Sun-like stars is beyond the capability of the space telescopes we have today. Plus, it takes too long, an entire year, to wait for a new transit. Planet TOI 175b is now on the list of habitable zone planets that can be examined more closely by the James Webb Telescope. Who knows? Maybe this awesome instrument will spot signs of an atmosphere surrounding the planet. Its presence, or absence, will depend on other properties of the planet, like its mass and size. Also, we need to figure out whether it can be classified as a water world. If it is, then its atmosphere, if present, will be more prominent and less difficult to detect than that of a more massive, drier, and denser planet, likely to keep its low-profile atmosphere close to the surface. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to figure out the planet's mass. Once they do it, they'll likely know whether TOI 715b is a watery terrestrial planet. By the way, if the second, yet unconfirmed Earth-sized planet turns out to be real, it will be the smallest habitable zone planet ever discovered by TESS. At the moment, James Webb is our best bet for observing the characteristics of these faraway worlds. But in the coming years, the next generation of ground-based, extremely large telescopes will be able to peer deeper into space, looking for new exoplanets.